Hello, good afternoon. This is going to be my code documentation for the midterm and final term Java game project. I am the only member. I decided to be the only member so I can have better control over what gets to be done and what can or cannot be put in the game. So, firstly, we have here our main class. It is simply just for executing the file from the start. We see here, this is where we create the, the first ever instance of the game panel class, of which later we will see that the game panel class handles the many other system classes that are used to make the game work, along with the entities, the player, the objects in the game. If we used it, we can also use it if we wanted to. We have NPCs and monsters. So yes, this yes, we just in the main class you at the game panel instance packet just to make it work. Now this is the where the fun begins. Set up game of the game panel. Now the setup method in the game panel, as you see here, this is where we begin to call the asset setter. We'll go into much better detail later. It sets the objects, sets the NPCs and monsters. It also starts the music if we wanted to, but I decided not to start it immediately. This is just a system out notification. Also, this game state is basically the state of the game, whether you are playing or you're in the title or in game over or whatever. Now, this is the core of the game, one of the core components of the game. You cannot run without it. The start game thread. In the start game thread, it creates a new thread, and you pass on the game panel instance of it, the game panel's own instance, and starts the game thread. Now, a thread is basically something that allows code to execute multiple times every nanosecond. As far as I remember, that's how fast computers execute. And when the game thread starts, it automatically calls the run method. Also, I forgot to mention the game panel extends the JPanel, which also implements runnable. The runnable interface allows us to use threads and allows us to override the methods from the thread. So when you call the game thread, it also calls the run method. This executes about 1,000,000,000 times per second, as far as I remember. Now, if a game thread executes code 1,000,000,000 times per second, there is going to be a problem. We cannot just move our character easily like what we saw in the video. It will actually fly out. The character will fly out of the screen the moment we hit the button. That is, it's not because the code is broken. It is simply in that code was executed too fast for us humans to notice. So this is where we use the double variable draw interval. It is a double and its value is equal to 1,000,000,000 because there are 1,000,000,000 nanoseconds in a second. And we divide it with our FPS, which is the frames per second we want, or rather, how many times we want to execute the code to execute per second, to set to 60. So 1,000,000,000 divided by 60 will return to this number of nanoseconds, and that will be our draw interval. Now this is I have too much to explain. What this basically does is that this will execute if the game thread is not null, and this gets the difference between the current time and the last time divided by the draw interval. This ensures that our update is executed only only 60 times per second. Because if the change in time is greater, if the change in time is greater than our drawing, the drawing interval won't execute. It updates the game details and repaints it. Basically, imagine a picture frame being made and updated very quickly. Also, the delta minus minus is simply just resets this. It does also turn negative, but that is fine. The code works anyways. This FPS clock, I remember using it last time for some of the game functions. The update method is a key method. Basically, updates, as I've said. Now, in this large update method, we see here if the game state is in a playing state, our slime is our player name. Slimes are plain. It updates the slime and it renders all the pieces in NPCs in a for loop and renders all the monsters in a for loop. And in case the upcoming NPCs now it won't touch it, same with monsters. I haven't really done much for the pause state other than that it pauses. I've done that in the UI class over here. Now, ow, my back. Ow. Now the paint component takes in the graphics G, as far as I remember. This was an overwritten method as well. This calls the super instance of the paint component. You get the graphics G and you get that graphics G to typecast it to 2D and you get our graphics 2D method. It comes with pre-built methods that we can use to draw our game or make our game. Now this was just used to check the rendering time because it doesn't really break the game. Now see here, the game is in title state. Our UI class will draw the title state. Okay. Other than that, we'll draw the tiles. Some tile manager. We'll go into that later. And the entity list, we add in the entity list. Basically, entities are our NPCs, our player, and our monsters. Were monsters? Yes, these monsters by the MON. Now, also the entity is a sort of super class. It has buffered images for the sprites, so they can change directions or sometimes they can bounce. So the area for their hitboxes, default coordinates for the hitboxes, collision, action lock counters, basically. So our action lock was used for regulating the movement of our NPC so they don't jitter on screen. Invincible is so we don't continuously take damage, and pretty much these are details for it. And basically, as for the construct of the entity, it takes in the game panel. It takes in the game panel instance, so you can inherit stuff from it. So you can also define the game panel. Set action is basically a method you can use with entity because we can just implement unique actions for each NPC or monster, since the entity superclass is extended by the monsters as well. Speak is what you can do if you want to speak with your characters. I remember what I did with this is you go to a character and just press enter to show up the dialogue. But in the Pac-Man game, this was not really used, but it was used back then to show dialogues. Now there's a switch statement here. Here it takes in the direction of our character when speaking to the character. The intended use is simply so that the NPC would face us rather than face away from us. As you can see, the slide, if our player's character is up, meaning we're looking from above, the NPC will look us from down, so he's facing us, same with left and right, us and others. As for the update, this is the method. As far as I remember, this is the method from the game panel, and this is method called from the game panel, and it updates everything in the everything. It updates every entity that extends from the entity class. As you can see here, the collision is defaulted as false, and then we get collision checker. Checks the tile if we are colliding with a solid tile. Example, if you see in the video, we were not colliding with the water tiles. And the object, in case we implemented objects, it parses this instance of the entity, and this is a boolean that checks if the one being checked is player or not. Check entity is the NPC, this one is the monster. Also, if collision does happen, the collision on the boolean, or the collision on boolean of the said entity will be turned on, and they will not be able to move. I remember that that thing was put yes, over here. See here, in this if statement, if collision is false, meaning after this the collision checkers were called and it was seen that there was no collision happening, collision will be set to false, and if the enter press is false. Now enter press was simply for the dialog buttons, as I mentioned a while ago. So if collision is false, you can move. Basically, the world Y and world X are the coordinates of our character or NPC or monster in the game. They're simply adjusted according to their speed, and speed is simply how many pixels they move per execution. For this one, it is 7 pixels per execution per 60th of a second. And this also sets a direction variable to up, down, or left. And yeah, it's also referenced there. So yeah, then these are the interactions of our player, in case it counts object or NPC or monster. But it checks the collision, let's go check the NPC. Now, interact NPC is a method which returns the index of that NPC. Now, this if index is not 999 is simply to mean if an NPC is detected. Now, I remember saying that you press enter to enter dialogue, but it was simply just not implemented in the game. What this means is the game panel, the enter pressed boolean, which was instance of the key handler, which was the instance of the game panel, is true basically if we press enter. If we press enter, it gives us a dialogue, and since this is a Pac-Man game where we delete the NPCs when we bump into them, we just get the game panel NPC, their index, and we just null them, delete them from the game. So that is why they disappear, and for testing we decided to play some sound effect from it. Now I felt, since I have I think 17 or 18 NPCs, all different unique characters, I decided to make a method that just takes the name of the NPC currently being taken and plays their specific sound effect. Yes, this is their specific sound effect. The sound effect is we see here GP, the game pan instance of play sound effect. Yeah, let's simply press that. Let's go back. Where is it? Okay, here. In the stop play SE, it just takes an index and as you just set file and place it. Now these are methods which are referenced in our sound class. This is the construction of the sound. This is now there's an array of music files, and you just put the directory, get class, get resource. This is what the index is referring to. Set file at the integer. You just set it, you open it, then play, you just start it. Loop, you loop, stop. Now let's go back to the. I think I was in the UI class, as I remember, right? Maybe. No, I was in the entity on this one, and I was reviewing this. Now this draw method, this as far as I remember, is being drawn. This is reference in our paint component class. The paint component method in the game panel class, it takes graphics 2D, and we got a buffered image, and this switch case statement, it's basically just meant for cycling through our images. Price that we set in our folder. I think it was in sprites, slime up, down. Let's zoom it in. We can't zoom it. What the heck? Just stay on. Okay, let's go back to the entity we're reviewing. Also, this one, invisible true. This is just a boolean that we regulate. So this is a boolean that we use so we don't take continuous damage from the monsters, since the game does execute very quickly. Alpha composite instance is used for lowering the opacity, so we know if we're invisible or not. Continuing with the entity, this is just for checking if the type is monster, NPC, or player. So type 2 is monster, type 1 NPC, type 0 player. Basically, it makes it so that if we contact the slime with the player, are invincible will be set to true. Invisible will be set to true, but our life will be reduced by 1. If collision on is false, as we mentioned, you do move, this for counter increases, and this is what was referenced over here. Now if it is 1, it just becomes 2, if it's 2, become 1, just so it cycles regulatively. Now in the draw method in the entity superclass, this the screen Y, screen X, these are basically the coordinates we see in the screen itself. That you see, as far as you notice in the game video itself, our character was always centered. This is the formula for that. Basically, world X is basically our coordinate in the world map, which means the world map is much bigger than what we render in the very screen itself, because our game window is only about 16 by 20 by 16 by 12 tiles. Meanwhile, our world map is 32 by 24 tiles, so it's much bigger. So world X minus the player's world X added to our screen Y. Basically, gives us the center. Direction. So this is for when we are pressing the keys. If we want to go left, it will render the right. Going to go left, it will render the left. Go up, it will render the up, and so on. Now, this is what as you notice, I only set it for left and right. That's because I only have left and right images for my sprites. I didn't have time to draw them. This is just overridden in my this is overridden. This draw method is overridden in my player class. That's why it's different. Now, buffered image setup. This is basically a method that helps us render images when we're setting them up. If they get an image, since our images are very small, like 24 by 24 pixels wide, it's too small to be seen. They are rendered according to each tile size which was set in the game panel. Open the game panel. Where was it? Tile size. Okay, tile size is basically the original tile size. It's basically 16 by 16. Original tile size scale 5. Now these variables were used for calculating how many ultimate pixels our game screen will be. That's basically what these do. They just regulate the coordinates and the height of the world, etc. Also, this tile size variable is very important. It was referenced multiple times as it was used to regulate the size of all images. So you notice it says utool. Utool is utility tool, or is it? It's simply oh, excuse me. I'm sorry. This is a public method in the utility tool that returns an image, it scans an image, it takes an image, it takes a width and height. So you just put an image in there, it will render it for you. And it returns that image. So notice width and height was always GP tile size. What's next? Oh yeah, since I talked about entity, let's go to each NPC. Each NPC is practically the same. It takes in the super instance of the game panel. Oh, and I forgot to mention our player. We also take in the super instance of the entity superclass, and TH is basically a key hunter. It's basically what allows us to just press stuff on the keyboard and stuff, and it moves. This just returns the midpoint of the screen. This is just the coordinates of our solid area. Every other entity has these. Also forgot to mention set default values. These are basically our default values. These are starting pointing the map by X and Y. Speed is how many pixels per 60th of a second we move. It's just the default direction. Any direction will do. Max life of our life. The default images. Just go set a method. The relative path of our sprite images. And yeah, Arisu is a bit special, so I put some dialogue in her. Sadly, it was just not used. So this is just some dialogue from inside dialogue. The data in the dialogue string array is the constructor. Set action. This is basically what allows our NPCs to move. Each of them has their movements regulated by some random number, and 25% of the time goes left or right or whatever. Just make it 50% left or right. Now, speak is just what allows the characters to create dialogue boxes. Now, dialogue boxes are, well, as far as I remember, it's speak method, or was it? Oh, there's this one. As you can notice, if dialogue index is not now, if it is not now, then we're going to speak, and also This procs our UI class to go to our dialog section. Where is it? This one. Just coordinates for displaying it, and coordinates for displaying it, and coordinates for width and height. Basically, the width and height of the text, as far as I remember. Yes, from the sub window. Since this draws a sub window. Just take in the font, set the coordinates of the font. Then we just print out the contents of the font in the sub window. Just the sub window, just text the coordinates within height. The color field is black, just like black. And this is the RGB. I mean, this 180 is just the opacity. So let's call it to C. Make a round rectangle, some stroke. So yeah, that's how the speak happens. Let's go to our monster. Just extends entity. It's practically just the same as an NPC. Also, the names are used for the switches for interaction specific stuff on NPCs or monsters. Now we're done with the objects are just they're just tiles that you put onto other tiles, and it extends entity. Pretty much just it. Just solid areas. Everything with solid areas. Just the hitbox coordinate and specifications. Tile class is just a buffered images with collision. Just for the tile manager is what helps us render the map. I think I should also start discussing the game panel files. Okay, so it takes in the game files constructor, it takes it in. Also, as you may have noticed, a good amount of these system files they take in game panel instance. That's because they're members of they are practically used all around with the game panel in the game threads, so they're not all working usually. It's basically array size of tiles, basically how many types of tiles you can create. The constructor, tile number, the map tile num. This is a very interesting bit. Map tile num is just is the index of the tile that is put into our world map when we are reading it. As you notice, the world map is composed of numbers. Each number corresponds to a certain index of tile, and the tiles is the set of method as we see it was in the UI class in the utility helper tool. Just this sets up this takes in the index. This sets an index for each tile. This fills in the image URL, the buffered image, and this is collision if the tile is walkable or not. This is the setup. See, it takes a new tool. Every tile index is instantiated as new, and you parse the path, gets scaled. The collision basically what you parse in there. Now this basically loads the images first. Basically just the images into the system. Now the load map is very interesting. This load map pass the world map text file, and This, this takes in the data from the map and just it's basically just this is basically just something like a 2D for loop from the Maxwell column, and well, this reads every number sequentially just like that, and this basically reads every line, and there's an array string array called numbers. It stops split every time there's a space. That's where they're all spaced, and that string turns into gets parsed as a number, and each of those numbers will be put into a 2D array in our map tile log over here. Basically, it creates a virtual version of this map into the computer, and each number is called accordingly as if in a table when you read it later in the load map in the in the draw pala. Now in the draw, just resets the word column and row. Then this is just a 2D, something like a 2D for you to just loops and prints out all of these indexed tiles according to their number. Now since we have like a virtual copy of it in our map tile num, it will call the map tile num index into the tile num and just draws it sequentially. The screen X and Y, this is basically the coordinate where it is drawn, and each time it is drawn, the coordinates are moved accordingly. That is why moved accordingly. And this one, yeah, world types plus world X is just adjusted every time this moves, save with screen Y. Next in the game panel, we must discuss is the key handler. Key handler, just a bunch of booleans to tell if our certain keys pressed or not. These are just overridden as let's keep this in. And this is a bit long, but it's a bit smaller and it should be just right. These are the operations if games in title state. It goes up to here. So many. So if you're pressing up, the GPUI command num goes minus minus, and if it is basically it's what allows our cycle the menu. Command num is greater than 0, just sets it to 2, and yeah, if you're pressing down and your command num is greater than 2, you set to 0. That is why if you look at the video, if you keep pressing up continuously in the menu, it just resets back to the down. That's because the command num is some sort of index that we use to coordinate the position of our cursor. Now let's just place the music right now. No, wait now. Display SE is play sound effect 8 was the index of our while boom sound effect. And the SE play is just used to regulate the play. Now, after this, no, within it, if you press enter, we are going to enter certain stuff. Load game, there isn't really stuff in it yet. Into is just exit the game. And press enter, we go title screen state 1 and play some music. Now title screen state 1, if it's 1, this is where we see the difficulty manager. This is just for cycling it, same thing. And if if you press enter, depending on the command status after pressing W or S, you get to pick the hard, medium, or the easy. And as you notice, you get different speeds and different life points depending on the difficulty. This is easy, this is medium, this is hard. This is the back. You simply go back to title screen state 0, and title screen state 0 is basically the first thing you see. Now if the game state is now playing, these are the ones that handle our movement, which was referenced as we saw a while ago in the entity and player class. Now this is just our debug for checking the render time. Now code event key M. This is the menu. We just reset. We just change the game state to the title state. Change the title screen state to 0, so we can go back to the main menu and start and stop music. Just stop music. Now it's just pause state. If the game state just pause state, games are just trying to play state. If we press P again. Dialogue is just some dialogue, and this is now if the game is game over, like when you lose all your health, it just calls the, as it said, this just resets the PC's monsters and the maximum NPC count, maximum score, resets player position, changes the game state to the title state, says game over to false, and so on. The same with game 1. Just resets the all eating game 1, game over. It just resets the game, that's what it does. The key release is just to see if the key is released. Next is the sound. This makes an array of music files. Just takes that stuff. This is just for setting the stuff up. I think we talked about this already. Collision checker is a bit difficult, but the main idea is that firstly this is takes in the instance of GP, and this one is a bit difficult, but this just basically takes the left word X, right word X, top word Y, and bottom word Y. This just takes in the coordinates of the top, bottom, left, and right of your entity or character or NPC or monster solid area. So left side, or I can say left side, right side, top, and bottom. The same. Now this column is just the left word X. This is just the mid. First, I think this is the Jesus reference pixels. It must be scaled down. Okay, there's a scaled down version of it. It's tile now 1 and 2. This is for checking our collision. Entity top row copy. It just sets a value for it. Checks left corner, checks right corner. Now if the tile manager instance of this certain tile collision is true, and the other one is also true, or the other one is true. Entity collision is true, and as we saw in our slime class, if your collision is in fact not false, it won't move. And it just repeats the process over and over again. Here, same with object, it's just a refactored version of it, except that this one is done in a for loop that checks for each entity as long as it is not null. The same so check entity here. Instead of using this rather tedious method of checking collision, we just use the rectangle method of intersects. It just takes in a certain rectangle file system and compares it with another entity. So that if it intersects, it just does these things. It returns the index, which as I may demonstrate, this is part of the track NPC. It takes in the index of this one, which allows us to do NPC specific things. And this is, and since the entity solidary X and Y and the objects X and Y are mutated over here, they must be reset to default. And that's pretty much just the same thing for check player and check entity. They just refactor it a little bit. Now going to game panel. Game panel. Game panel. Asset setter. Let's go to the asset setter. Oh, oops. Asset setter. Oh, this just sets this just lets us create new instances of NPCs or whatever. This set NPC or whatever it's called inside the game panel. Setting the stuff up. This was also used for resetting the game. As you may notice, the word X and Y are set as 3 types GP tile size or 4 types GP tile size. This is simply because we use. Wait, let me demonstrate how we use this. For example, you see here you want to put a certain character on this tile. You take its certain coordinate, the coordinate is, let's say, x4, y12. If you take the x4, y12 here, you scale it by the GP tile size. That's because tile size this is basically just a miniature version of the wait, how do I say this correctly? The screen is the coordinates in the screen are actually by pixels, but setting the coordinates strictly by pixels only is quite tedious and hard to do. So we just use tile size as a multiple. Each tile size is 80 by 80, by the way, because since it is 16 by 16 multiplied by a scale of 5, that's what we do. So yeah, this just sets it up. And go back to the game panel. In the game panel, we see UI class. I'm sorry for my voice. I'm a bit tired, unfortunately. Yeah. UI class. These are just booleans and stuff we use for sure for checking and checking stuff. And also this font Minecraft is just a custom font they downloaded and put in a folder, so you can get a pixel font. This one just sets the values and the heart. These hearts are what renders are hearts. Show message makes messages, dialogues, it sets dialogues and sound effects, whatnot. The draw method is very interesting, but what is drawn depends on the title, on the game state, whether it's title play or pause or dialogue. Each of these states call their own draw method, which is made within here. These are just a bunch of text with color coordinates, a bunch of boolean checkers as well. Now the player state, draw player live, it's just a for loop that draws either blank hearts or full hearts depending on the player's current life. So I'm rushing a bit, but the video is just a bit too long now. The title screen is just this executes only the title screen set to 0, meaning if we are in the main menu, and that's the stuff. It's just a bunch of code coordinates. Now if the title screen is like this one, just pick the difficulty. Pause screen is just pause screen. Dialogue screen is just a bunch of dialogue. Some variables for just some variables for the window. Just parse it here, get center text, just gets the center point of the text X. Draw notifications, just if there's something interesting that you use in the game, it's just the prompt text that draws even if you're in play state. Next, event handler. This basically, well, what is this? Oh, this just creates some. This just creates hitboxes that you spread out on each tile in case you want to associate that hitbox with a tile. That's why it is in a 2D array. Just check event to just get the absolute distance of the player from the event. And, yeah. This one is just used so you don't repeatedly execute an event, so since the computer executes really quickly. Also, this is also you may have noticed in the game there was a spot where you can press enter. You would hear this is it here, and the enter one is the enter prompt is by this one. This one is just this. The dialogue set is called from the UI class, and this one is just some mini collision, some sort of mini collision checker. These are just dialogues and the effects of the player status. Teleport is just changes your word X and Y real quick. That's why it looks like you're being teleported. Get thread is just get thread, and I think I'll just talk about the main code a bit more. So the code in its simplest form is basically just stuff in it gets updated real quick, and there's just this for loop in the update method that happens while you're in play state. It updates the slime continuously, it updates all NPCs continuously, it updates all monsters continuously. And its pause state, it doesn't nothing happen. In the pin component, uh, this is these entity lists add whatnot. They just load the entities into an entity array list. Collections just sorts them so that they are in the right rendering order. So when you characters overlap, they overlap correctly. I think that's it. It's yeah, I think that's it. Thank you.